Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where 2 major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where 2 tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding axial patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids: blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, Scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer, made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year, because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
It was April 2025 when geologists went back to Yellowstone's Norris Geyser Basin for the first time this year. And while doing their usual check, they realized that something was different this time. Where there used to be just a boring patch of ground, now there was a giant hole, about 13 feet wide, filled with weird, milky, light blue water. Everyone was terrified. Was it the sign that the Yellowstone supervolcano was ready to erupt? If so, it would be a worldwide disaster, the kind that destroys cities. According to the U.S. Geological Survey, if such an eruption occurred, the after effects would be felt all over the world. To start, the areas immediately surrounding Yellowstone would experience pyroclastic flows. That's the lava that erupts out of a volcano, including a high-density mix of volcanic gas, ash, pumice, and hot lava blocks. Those flows would destroy everything they touch, and an eruption of Yellowstone would send them into Wyoming, Idaho, and Montana. Areas further away from Yellowstone would escape the flows, but they would experience falling ash. It would come down heavily in the states closest to the epicenter. The ash would be especially dangerous for anyone breathing it in. The weight of the ash would also pose a serious threat. It would smother crops and collapse buildings as it piles up. Tragic consequences would be countless, but we'll talk about them later, because soon after the discovery, the weird pit surprised even experts. Geologists found rocks scattered everywhere. Some were about a foot across, and all of them were dusted with gray mud. This mud matched the walls of the new spring. It was like the place had simply exploded, but nobody had actually seen it happen. The team checked old satellite images to figure out when it appeared. In December 2024, the ground was totally normal. By January 6, 2025, a little dip had formed. And by February 13th, that water-filled hole was finally there. But the weird thing was that the sensors that usually pick up major hydrothermal explosions didn't detect anything. There was no giant blast or warning signs. Later, it turned out that this puzzling opening in the ground hadn't just popped up in one huge explosion. Instead, it formed from a bunch of smaller bursts over time. Little explosions first threw out rocks, then mud, and eventually created the pit. With time, it filled with silica-rich water. That was a huge relief for everyone. Yellowstone sits on a supervolcano, and its big explosions are a nightmare scenario. Luckily, this time, it was just a slow-building, small-scale explosion. It was dramatic, sure, but totally manageable. You see, Yellowstone National Park is full of geysers, hot springs, and all kinds of natural landscapes. But under the surface, things get incredibly intense, all because of the supervolcano. Now, supervolcanoes are often extremely large. They often have no cone at all, since they're typically the remains of gigantic magma chambers. Once, those chambers flared up, leaving behind a caldera. They're usually located over hotspots. It's no surprise that supervolcanoes can produce super eruptions, and when they do it, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes form when huge volumes of scorching hot magma escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. So, a pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more and more magma is trying to get to the surface. And then, bang, a super eruption occurs. Now, back in 2015, researchers at the University of Utah mapped out the main magma chamber of the Yellowstone supervolcano and were shocked by its size. And then, they found another one below it. Together, these underground magma pools could hold enough molten rock to fill the Grand Canyon 11 times. All that magma pushes up on the ground above, which is why Yellowstone rises about an inch or two every year. That slow lift might not sound like much, but combine it with the fact that Yellowstone is still an active volcano and has a volcanic explosivity index of 8, and it's enough to make you wonder what could happen if things went south. And yes, Yellowstone has indeed been a bit jumpy in recent years. In March 2023, there were 354 earthquakes in the area. Most were tiny, but the biggest hit a magnitude 3.7, part of a swarm of 106 quakes. Now, before you freak out, experts from the Yellowstone Volcano Observatory say there's no need to panic. No eruption is coming anytime soon. Volcanoes don't stick to a schedule. Just because Yellowstone hasn't erupted in a long time doesn't mean it's about to blow. The park is stable for now, but scientists are keeping a close eye on everything underground, the quakes, the rising ground, and even temperature changes, just to be safe. The superhot plume of magma, a hotspot under Yellowstone, has been churning for 17 million years. The Earth's crust slowly moved over it, making the hotspot leave a trail of volcanoes stretching more than 450 miles along the Snake River Plain. Most of those ancient ones are now buried under layers of lava and sediment. In just the past 2.1 million years, Yellowstone has unleashed 3 cataclysmic eruptions, so massive they managed to reshape the land. Each explosion sent pyroclastic flows, rivers of searing hot rock, ash, and pumice racing outward for miles. The debris piled up in layers hundreds of feet thick, some forming solid lava-like rock. When those eruptions emptied the underground magma chambers, the roof collapsed, forming the massive calderas we see today. Even after those mega eruptions, Yellowstone didn't stop. Between 180,000 and 70,000 years ago, enormous rhyolite lava flows, sometimes over 144 cubic miles, poured out. Some flows followed north-south vent lines. The West Yellowstone flow erupted around 110,000 years ago. The Nez Perez Creek flow followed 160,000 years ago. If you stand at Madison Junction on the caldera's northwest rim, you can see it, a cliff that formed when the Lava Creek Tuff eruption collapsed the land 640,000 years ago. And inside the caldera, you'll see the hardened lava flows snaking across the floor. Figuring out when a supervolcano might blow is like being able to read nature's warning signals. Thousands of years before a massive eruption, the heat underground starts building, and the magma chambers become like ticking pressure cookers. Little signs start showing up. Gas bubbles escape as the pressure shifts, and earthquakes shake the ground. The land above slowly rises. Cracks appear. Hot springs and geysers start acting up, heating even more than usual. Now, what would happen if Yellowstone erupted? Remember those pyroclastic flows we talked about before? They can contain two parts: the lower flow of the hot lava that moves at ground level, and a cloud of ash that follows above the lava level. So the two of them would devastate huge areas. The ash would even reach Europe within 3 to 4 days of the eruption, but it wouldn't be so bad there. After that, it would only take around 2 to 3 weeks before cooler temperatures set in around the globe, all thanks to the sulfur gas that would get to the upper atmosphere after the eruption. Scientists predict that global temperatures would drop by up to 10 to 12 degrees. These consequences could last for 6 to 10 years, putting an end to monsoons, which could cause widespread famine in Asia. Scared? Well, don't be. The good news is that scientists don't believe that the sleeping giant under Yellowstone National Park will wake up in our lifetime. Experts say the next Yellowstone eruption won't likely happen for hundreds of thousands of years. And even then, it may not be that bad, because scientists have discovered that the magma lurking within Yellowstone is actually split up amongst 4 different chambers. Not only that, but some of the reservoirs of magma are likely to cool down and solidify, lessening the chances of an eruption. So, while an eruption does sound like it would change the landscape of the world, it's very unlikely to happen anytime soon.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Urubuntu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Urubuntu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Urubuntu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington state in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it. About 2 billion years ago, a massive asteroid crashed into Earth, leaving behind total destruction and what we now call the Vredefort crater in South Africa. And get this space invader might have been way bigger than scientists originally thought, possibly twice the size of the asteroid that wiped out the dinosaurs. Nowadays, the Vredefort crater is about 99 miles across, which makes it the biggest visible crater on Earth. But technically, it's still smaller than the Chicxulub crater in Mexico. The latter is about 112 miles, and it was left by the infamous dinosaur distractor 66 million years ago. But the thing is, craters don't stay the same forever. Over time, erosion wears them down. That's why they start looking smaller than they used to. And scientists think that when the Vredefort crater first formed, it could actually reach 174 miles across. That means it was the biggest impact site Earth has ever seen, even though it looks smaller today. Just imagine how insane that impact must have been. A space rock that would have sent shockwaves ripping across the planet, triggered enormous wildfires, and completely changed the climate. The asteroid likely hit Earth at a very, very high speed. But since this catastrophe happened billions of years ago, way before dinosaurs or even complex life saw the light of day, it didn't wipe anything out like the Chicxulub asteroid did. At the same time, recently, researchers have realized that the asteroid might have been even bigger than they thought previously, up to 15.5 miles wide. As for the speed at which it slammed into Earth, it could reach a staggering 56,000 miles per hour. Now, figuring out how big Vredefort originally was, that's been a bit of a headache. The main issue is that it's super old, and we're talking about 2 billion years old. No wonder that over that much time, erosion has kind of worn it down, so it's hard to tell just how huge it once was. But it's not just erosion causing the problem. Over the years, new layers of rock have built up over parts of the crater, and they've covered up most of the original structure. That's why now only little pieces of the raised rim are left, and this makes it even harder to get a clear idea of how big it was. So, scientists started looking at the minerals around the crater, like quartz and zircon. They discovered that those were all messed up by the asteroid's impact. They had tiny fractures caused by the blast. Researchers studied those damaged crystals and managed to figure out how far the explosion actually spread. Equipped by this new knowledge, scientists now believe that their latest estimates of the size of the asteroid are the most accurate ones. The reason why we haven't heard much about this disastrous impact is that, unlike the Chicxulub asteroid, which wiped out the dinosaurs and reshaped life on Earth, the Vredefort asteroid hit at a time when Earth was a very different place. There were no trees, no animals, just single-celled life in the oceans. That means no mass extinction, no burning forests, no fossilized evidence of chaos. But scientists think it still had a massive impact on the planet. It might have changed the climate even more dramatically than the asteroid that ended dinosaurs. But since we don't have much direct evidence of the disaster, studying what's left of the Vredefort crater is one of the only ways to understand just how powerful this impact was. Even though it happened billions of years ago, learning about this impact can help us understand the history of our planet, and maybe even prepare for future asteroid threats. After all, they could be similar to what happened in Siberia at the beginning of the 20th century, pretty recently. It was a warm morning, June 30th, 1908, when the sky suddenly lit up with a blinding flash. What followed was an explosion so powerful that it remained a mystery for decades. Known as the Tunguska event, it was one of the most baffling disasters in history. Scientists suspected an asteroid impact, similar to the one that wiped out the dinosaurs. But there was one eerie problem. No crater was ever found. The explosion struck deep in the remote forests of Siberia, near the Podkemenaya Tunguska River. The blast was beyond anything seen before, flattening around 80 million trees across an area of 830 square miles. The sheer force of the event was mind-boggling. It was strong enough to devastate the landscape, scorch the ground, and wipe out countless animals. According to witnesses, there was an eerie glow in the sky, which was followed by a streaking fireball with an intense bluish light. It was brighter than the sun. Moments later, there was a deafening blast. The shockwave was so powerful that it shattered windows hundreds of miles away, and people were knocked off their feet. Yet, despite the destruction, the source of the explosion left no obvious trace. Later, scientists finally started to understand what had occurred on that day. Imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up all of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. And since the explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface. Another wild story happened back in the late 90s, but it wasn't Earth that was affected. A comet got stuck in orbit around Jupiter. One day, it got too close, and Jupiter's immense gravity broke it apart, turning it into a bunch of pieces. Some of them were as big as half a mile across. Scientists were curious because they didn't know what would happen when those pieces hit the planet. And in July 1994, the moment came. The comet's broken up pieces started crashing into Jupiter, one after the other. Over 6 days, 21 chunks of the comet smashed into the planet at insane speeds, like 37 miles per second. That's more than 130,000 miles per hour. The impacts were so powerful that they heated up Jupiter's atmosphere to a mind-boggling 53,000 degrees Fahrenheit, which is way hotter than the sun's surface. When each chunk hit, it sent massive plumes of material flying out of Jupiter, like when you throw a rock into a pond, but way bigger. Some of these plumes shot up almost 1,900 miles into the sky. Afterward, big dark scars appeared in Jupiter's atmosphere, and they stayed visible for months as the debris spread out across the planet. But this wasn't just a cool space event. Scientists actually learned a lot from it. Those dark impact marks helped scientists track the winds in Jupiter's stratosphere. The crashes even caused temporary changes in Jupiter's glowing auroras, showing that the planet's magnetic field was affected by particles from the explosions. Plus, the comet fragments didn't just make a mess, they also left behind new chemicals in Jupiter's atmosphere. Plus, some chemicals were also exhumed from the lower atmosphere. Some molecules like ammonia broke down over time, but others like hydrogen cyanide and water are still floating around Jupiter today. This helped scientists understand how different chemicals react and mix in Jupiter's atmosphere. Comet Shoemaker-Levy 9 was a wake-up call. It proved that massive space collisions still happen in our solar system. That's one big reason why NASA started looking into how we can track and prepare for any future impacts that might threaten Earth. Whether it's learning more about asteroids and comets, or about how giant impacts shape planets, the importance of such discoveries is undeniable.
We all know that space missions come with a hefty price tag. To break it down, a ticket to space for an astronaut starts at around $20 million and can soar up to $50 million. NASA may be a well-funded organization, but you can bet they're always on the lookout to cut costs and save millions wherever they can. Plus, NASA has long realized they do not need to go to Saturn's moon to study if there's life there. We already have the suitable conditions for extraterrestrial life in Wyoming. If that resonates with you, then you already understand why NASA is so interested in Yellowstone. To explore life beyond Earth, we need to study environments that mimic extraterrestrial conditions. That's where all those hot springs come into play. Now, it's not the entire park that piques NASA's interest. Let's leave the bears, moose, and other Earthlings to our local biologists. The real hotspot is the geysers, where microbial life flourishes. Oh, by the way, Yellowstone has more geysers and hot springs than the rest of the world combined. In some of them, water can reach temperatures as high as 192 degrees Fahrenheit. You might think, hey, that's only good for steeping tea. But here's the thing. Life in the form of microbes not only survives but thrives in these extreme conditions, having adapted specifically to them. So, could these microbes help us find life on other planets? Absolutely. Now, let's shine the spotlight on the real superstar, the Grand Prismatic Spring. It's packed with silica, which gives it that stunning color. Silica reflects sunlight, especially the blue wavelengths, which is why it looks so vibrant. The coolest part, though, is not the color, but the fact that this spring can teach us a lot about how life evolved. Way back around 4.5 billion years ago, I wasn't around then, living things didn't know how to harness energy from sunlight yet, so they were using chemical processes instead, just like they do now at the Grand Prismatic Spring. But why are we talking about other planets? Well, if life on Earth kicked off in a comparable way to what we see in Yellowstone, there's a good chance we could find something similar elsewhere in the universe. And if we could nail down exactly how life started here, we could really fine-tune our search for life on other planets. Geysers, very similar to those in Yellowstone, can be found on moons like Enceladus, which orbits Saturn, and Triton, which is a moon of Neptune. But how do they compare to the geysers we see in Yellowstone? Well, back in 1989, NASA's Voyager 2 spacecraft made a groundbreaking discovery when it spotted geysers on Triton. This was the first time anyone had seen a geyser outside of Earth, not counting the volcanic eruptions on Jupiter's moon, Io, that were found by Voyager 1 in 1979. Since then, more geysers have been found on other moons in our solar system. In Yellowstone, geysers are heated by hot water from deep within the Earth. However, geysers on some of the outer moons get their heat from tidal forces, the gravitational pull from the big planets they orbit. You know how ocean tides on Earth are affected by the moon and the sun? Well, these moons experience something similar, but on a much larger scale. Beneath the icy surfaces of these moons are warm, salty oceans that stay liquid because the thick ice above keeps them insulated. As the moons move closer and further from their parent planets, the constant tugging creates heat, causing the warm water below to shoot out into space whenever there's a crack in the ice. This icy crust and the warm water underneath are a bit like a frozen pond on Earth. But could there be life swimming around in these hidden oceans, just like there are critters thriving beneath the ice of a pond? That's something scientists want to find out. NASA hopes to send advanced spacecraft to explore these distant moons and look for signs of life. But those warm oceans are buried miles beneath the frozen surface. So, how do we reach them? The answer may lie in geysers. In February 2019, a group of planetary scientists decided to visit Yellowstone in the winter to study the similarities between Earth's geysers and those in space. They know that Yellowstone's geysers are home to some tough little microbes called extremophiles, which thrive in extreme conditions like hot or acidic water. The researchers wanted to learn as much as they could about these microbes and the environments they live in. They brought along a bunch of scientific tools to measure things like temperature, pH levels, and oxygen in the water. They also used special instruments to analyze the chemicals in the ice and rocks and sniff the air for gases. Plus, they collected samples of rock, ice, and water from the geysers, catching tiny droplets on sheets of foil coated in geyser spray. Their main target was the Great Fountain Geyser in Yellowstone's Midway Geyser Basin, which puts on a spectacular show 2 to 3 times a day. However, visiting in winter posed some challenges. Some scientists were delayed by snowy weather, arriving late at night right before they were supposed to enter the park. Then their SUV got stuck in a snowdrift and had to be rescued by a snowplow. The next day, riding in a snow coach, the team had to trudge through deep snow for nearly a mile to reach the geyser, keeping an eye out for elk, bison, and even bears. As they made their way to the Great Fountain Geyser, they took breaks to gather samples and measurements from other interesting pools along the way, like Lemon Pool and Surprise Pool. Even though Yellowstone feels remote, it's not nearly as far away as places like Enceladus and Triton. It's a unique natural laboratory that can teach us a lot about life on Earth and potentially beyond. Oh, as for labs, the Great Prismatic Spring may count as one. Look at these guys. Under the microscope, they look like matches. Their official Latin name is Thermus aquaticus. They live in this hot spring, and these bacteria have saved millions of people's lives. Now, if you're skeptical about what I just said, then you need to know that these bacteria help to create the basis of PCR tests widely used in today's medicine to give fast and precise diagnosis. Back in the 60s, a microbiologist named Thomas Brock was exploring the park's superheated thermal pools and stumbled upon something amazing. Brock was super interested in bacteria that could thrive in extreme conditions. During his 10-year journey studying geysers and thermal springs, he found a microbe in a spring called mushroom pool that could survive in nearly boiling water. This little guy, Thermus aquaticus, turned out to be a game changer for science. Why? Well, it's crucial for a technique called PCR, also known as polymerase chain reaction, which is used to quickly make copies of DNA samples. Before Brock's discovery, this process was tricky because the heat could damage the enzymes that hold DNA together. But thanks to Thermus aquaticus, scientists could now heat and cool DNA samples without breaking them down, making everything faster and easier. It all happened because researchers had purified an enzyme called tag polymerase out of this organism. Those Yellowstone microbes could also be your new go-to for a delicious and sustainable breakfast. A unique microbe was discovered there during some NASA-funded research, and it's now being transformed into tasty vegan breakfast patties and cream cheese. Originally found in a hot spring, this little wonder is called Fusarium strange flavolapsus, and it caught the attention of space enthusiasts as a powerful protein source for long space missions. Plus, it requires way less water and land than beef, making it a smart choice for the planet. Researchers initially looked at this microbe for biofuel, but soon realized it could be cultivated into a complete protein with a texture reminiscent of chicken. Marked as FY, it can be turned into a variety of food products, all thanks to a fermentation process that keeps it free from contaminants. Oh, almost forgot. NASA is even working on a bioreactor to grow FY in space. Ooh, stay tuned. Oh look, there's a giant blob heading straight for New York City. Oh wait, hold on. You'll actually have to look down, not up. Because this blob is a mass of hot rock moving beneath the Earth's surface. And when it finally reaches the Big Apple, some say it could tear the continent in two. But Yankees fans, and even you Mets fans, don't worry, this journey is going to take about 15 million years or so. You see, a long time ago, people noticed something curious. When they looked at world maps, they thought, don't the continents look like puzzle pieces that could fit together? That couldn't just be a coincidence, right? Then, in the year 1912, a German meteorologist named Alfred Wegener came up with a revolutionary idea, something we now know as the theory of continental drift. Wegener said the continents are always on the move, and those huge chunks of land we see today were all once connected, forming one giant supercontinent called Pangaea. That idea suddenly explained a lot of mysteries, like why fossils from the same species turn up in different corners of the world, even though entire oceans lie between them, or why coastlines of continents match up so neatly, just like South America and Africa. Wegener also explained that mountains form when a drifting continent runs into another one, crumpling the land and pushing it upward. That is exactly how the Himalayas came to be. The Indian plate collided with the Eurasian plate, and the land rose into the massive mountain range we see today. Now these days, everybody learns about Wegener's idea in school and takes it as fact. But back then, many people thought he was completely out of his mind. I mean, whole continents moving around? What on earth could push them? That's why it took scientists more than 50 years to finally go, oh, I see, it's the Earth's mantle. Yep, slow-moving currents of hot rock deep in the Earth's mantle push the tectonic plates around, and that means the continents move too. Picture super tough puzzle pieces floating on top of boiling oatmeal. That's a picture. Yep, they drift, and sooner or later they crash into each other. This is what happens on Earth's surface. And that's how we finally agreed that Wegener was right. But what if I told you that might not always be the case? Some experts agree that the supercontinent Pangaea started breaking apart about 200 million years ago. And that's how we ended up with the world map we know today. But a recent study is challenging part of that idea. And it all comes down to a giant mass of hot rock, something scientists call the Northern Appalachian Anomaly, or just NAA. Yep, what we casually call a blob, the experts call an anomaly, and that is simply because it is hotter than the rock around it. So this anomaly sits about 124 miles beneath the mountains of New England and stretches up to 249 miles wide. It lies in the asthenosphere, the semi-molten layer of Earth's upper mantle. But here's the strange part. It should not even be there. I mean, rock formations like this normally don't exist in that part of Earth's interior. For years, scientists thought the anomaly was left over from when the North American continent broke apart from Northwest Africa about 180 million years ago. This new study says that might not be the case. It suggests the blob is actually linked to the process that split Greenland from North America only about 80 million years ago. The idea then is that this blob is a leftover from when the landmass broke apart, a piece that never quite settled down. This is one stubborn blob we're talking about because it is still on the move, super slowly. But still, it moves only about 12 miles in a million years. Over time, it's already traveled more than 1,100 miles from where it first appeared. And now, New Yorkers, watch out! This blob of scorching hot rock is heading your way. Okay, I know, I'm being a little dramatic. The truth is, we really don't have to worry. First, scientists say it won't even get near the city for at least 15 million years. And second, even though we call it a blob, it is not something gelatinous. It is not oozing. And it is definitely not going to push its way up through the Earth's crust and invade the New York subway, or anything like that. That is just not going to happen. What the anomaly will look like, or what it might do to the continent in the future, is still a mystery for geologists. But they are pretty confident it will not have any real impact on human infrastructure or on our daily lives. It is not like lava that's suddenly going to burst through the floor of your house. That's because, at the end of the day, the blob is just rock. Like any rock you see on the street, only super high, enormous, and buried deep inside the Earth. To explain why this rock is sitting in such a weird spot, scientists came up with what they call the mantle wave theory. So think of it kind of like a lava lamp. After continents break apart, hot, heavy rock can detach from the bottom of the tectonic plates in blobs. These blobs, or pieces of rock, move around under the crust and create waves. When that hot material slips under a continent, it works like the flame under a hot air balloon. It gives the land a little lift. Then, when continents stretch and split, space opens up underneath and semi-molten rock quickly fills in. Eventually, it cools down, gets heavier, and sinks. Meanwhile, hotter mantle material rises up and creates a warm patch called a thermal anomaly. This sudden motion shakes up the base of the continent. Imagine a row of dominoes. One piece falls and the rest follows. Blobs of rock start dripping downward one after another, and over time, they slowly move inland. Scientists think these rock currents keep flowing, rippling under the surface for millions of years. Now, knowing all this matters because the anomaly might have played a role in shaping the land above it. For example, it may have lifted up some ancient mountains over the past few million years. That helps to explain a big mystery of the region: why the Appalachians are still standing. I mean, why haven't they worn down as much as you would expect after all this time? Well, think about it. The Appalachians are ancient. This mountain range in North America started forming hundreds of millions of years ago, long before the dinosaurs. With all that time, rain, wind, and erosion should have worn them down to almost nothing by now. Honestly, some geologists expected them to be rolling hills at best. But nope, they're still mountains, pretty ones too, and much bigger than they should be. And here's where the blob comes in. See, when a giant pocket of superhot rock sits under a mountain range, it can actually give the crust a little lift. It's kind of like putting a balloon under a blanket. The blanket rises up. The heat makes the Earth's crust lighter. So even while wind and rain are wearing the mountains down from above, the Earth is gently pushing them back up from below. There is another positive takeaway from this study. These new insights can help scientists better understand other strange geological features around the world. In fact, the researchers believe they may have already found a twin to this blob, sitting under north-central Greenland and also tied to the Labrador Sea. So, what can we conclude from all this? Well, tectonic plate movement is still the reasons continents break apart. But the process goes much deeper than we thought. The effects of ancient rifting can still play out millions of years after the surface split, just like what happened in Greenland. Although it's still really hard to predict what this anomaly will look like in the future, we know one thing for sure right now: there is nothing to fear, and I'm betting that most of us won't be around for that. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Erupted in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only two confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
Your geography teacher must have told you there are 7 continents in the world. In 2017, scientists made an announcement that changed this universal truth: the discovery of Zealandia. They called for a change in world maps and provided us with some proof, of course. First off, let's take a look at the ocean floor near New Zealand. The continental shelves of this mysterious continent are chilling at a depth of around 3,280 feet below sea level. The nearby oceanic crust dives even deeper at 9,800 feet below that. All of that is giving us those continent vibes, with varying altitudes from deep below the ocean to the majestic Mount Cook, standing tall at 12,217 feet above sea level. Brave geologists have gone deep down to collect rocks from the ocean floor. They've found that unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is one impressive mix. We're talking granite, limestone, sandstone, and some ancient rock types that are incredibly ancient. All this screams continental crust. Finally, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the Earth's tectonic plates, those puzzle pieces that make up our planet's crust, started throwing a wild party. The mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. This process is called subduction. As a result, the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. So you see now that it takes millions of years and a lot of action for a new continent to form. But what if the impossible happened and a new continent formed overnight in the Pacific Ocean? The next morning, you'd probably spill your morning coffee while watching the news. For this newfound land to be considered a full-fledged continent, it needs to have a surface area like Zealandia and be a large, uninterrupted chunk of land with some water surrounding it. And here comes the twist. The Pacific Ocean has an average depth of 13,000 feet. So, if a continent wanted to join the party, it would have to push a whole lot of rock upward, shaping its way to the surface. A new continent emerging overnight would make sea levels skyrocket. We'd have to say goodbye to geographically low-lying countries like Bangladesh, Senegal, and the Netherlands. The ocean currents would be in for a wild ride too. The North Pacific subtropical gyre, a vibrant hotspot for marine life, would be thrown off balance. Those poor marine creatures who rely on the currents for their journeys would need some new source of navigation. Plus, the creatures that live permanently in one place could lose their main food source. Oceans are like global free-for-alls, but with a new continent in play, the countries situated nearby would be willing to stake their claim on this unexpected landmass. This new continent would be a blank canvas. No lush landscapes or freshwater sources, just rock and more rock. So, if you were dreaming of relocating to this novelty, you have to wait for some serious terraforming to make it habitable. But for now, let's go back to the real new continent of Zealandia. It's actually a microcontinent, which is an official word for a landmass that has separated from a main continent. In our case, it was Antarctica and then Australia. You could say Zealandia is a bit shy, with only up to 7% of its size peaking above the water's surface. But it's nearly 70% as large as Australia in total and proudly boasts of two major islands we know and love as New Zealand, the North Island and the South Island. Plus, there are many smaller islets. The largest islands have glaciers, like the famous Tasman Glacier on the South Island. Thanks to some glacial action in the past, Zealandia can show off its fjords and valleys. New Caledonia has a tropical vibe with its Oceania and South Pacific connections. The unofficial 8th continent is a hotspot for geological action. Part of it belongs to the Australian plate, while the rest rides the Pacific plate. It has 6 major areas with active volcanoes. And don't forget the geothermal treats. Geysers and hot springs are scattered all over the place, courtesy of the Australian and Pacific plates having a steamy interaction. The underwater world of Zealandia is a treasure chest of mineral deposits and natural gas fields. It's also a scientific playground. During those icy glacial periods, sea levels dropped and more of Zealandia emerged from the depths. The fossils this process left behind are like an encyclopedia of valuable clues about the life that thrived here during ancient times. The search for Zealandia lasted for 375 years. It all started in 1642, when Dutch seafarer and explorer Abel Tasman set on a mission from Jakarta, Indonesia. Back in the day, Europeans were sure that there had to be a massive land down under to balance out their own continent up north. They even had a fancy name for it, Terra Australis. Tasman was determined to become the first to find it. He went west, then south, then east, all the way to the South Island of New Zealand. But here's where things took a turn for the worst. The local Maori people, who had been living there for centuries, didn't exactly roll out the red carpet. They rammed one of Tasman's small boats, and sadly, 4 of the Europeans met their ends. What happened next remains a mystery. But a few weeks later, Tasman sailed back home without ever stepping foot on this mysterious land he believed to be the Great Southern Continent. He never came back. The explorer didn't even realize that he was actually right all along about the existence of a missing continent. And you already know it only became official in 2017. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called the Greater Adria, and it collided with Europe and started to sink under it around 140 million years ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape matched that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. You don't notice this, but our planet never stops moving, and it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent landscape was probably much like that of New Zealand. Our planet keeps changing, and at some point, all the continents will reconnect with each other, forming one supercontinent again. And maybe then, future humans will wonder, what if our continent broke into pieces tomorrow? It's the 15th of January, 2022. 4:47 p.m. local time. It will start any moment. Here, do you feel these jolts? The South Pacific is about to experience one of the most powerful volcanic eruptions ever recorded by modern instruments. The eruption begins at Hunga Tonga Hunga Ha'api, an underwater volcano in the Tongan archipelago. The eruption itself is enormous. Its volcanic explosivity index is at least VEI 5, with the maximum being 8. It's as powerful as such historic catastrophes as Mount St. Helens in 1980 and Mount Vesuvius in 79 CE. The eruption releases a staggering 2.4 cubic miles of volcanic material and sends over 150 million tons of water vapor into the stratosphere. This amount of water vapor would have been enough to fill 58,000 Olympic swimming pools. Additionally, the eruption generates the fastest underwater currents ever recorded and triggers large tsunamis that struck areas as far as Peru, more than 6,200 miles away from the volcano. And it takes at least 4 lives, with even more missing. But the craziest thing is that just before the eruption, 15 minutes ahead of time, there was a kind of warning. But as it often happens, people simply missed them. Two seismic stations, about 466 miles away from the volcano, which is pretty far for this kind of thing, picked it up. They figured out it was a Rayleigh wave, which is a type of seismic wave that moves along Earth's surface. This wave was caused by a fracture in the ocean floor, where magma and seawater started to interact under a lot of pressure. That's likely what triggered the eruption. The crazy thing is that normally, volcanic seismic signals are pretty small and can only be detected close to the volcano. But this Rayleigh wave traveled way farther than usual and was much stronger. It means there had to be a massive amount of movement going on beneath the surface before the eruption. While people on the ground didn't feel it, those distant sensors picked it up. And this discovery is great for identifying volcanic threats earlier in the future and for improving early warning systems. If scientists can detect these seismic precursors, they could give a heads up before an eruption happens. That would give people time to evacuate and reduce the chances of injuries or property damage, especially for underwater volcanoes like this one, which can also trigger fatal tsunamis. Now, the eruption was big, but its impact was mostly contained. However, this discovery underlines how important seismic data is for predicting and preparing for these disasters. Even though this precursor wasn't used to issue a warning during this eruption, the idea that we could use this kind of information in real time during future eruptions is really promising, especially for underwater eruptions, which apparently might give us more warning time than we thought. Even though we wouldn't have been able to hear that precursor warning signal, there is a sound so loud it could actually finish you. And while such sounds are incredibly rare, the loudest noise ever recorded was indeed fatal to those who were close enough. On 27 August 1883, the eruption of the Krakatoa volcano in Indonesia created the loudest noise ever measured. It's thought to have been an astonishing 310 decibels at the source. To put this in perspective, a hand drill produces the sound of 98 decibels. The noise produced by a jet engine measures 140 decibels. And the sound of 180 decibels is capable of destroying your hearing tissue. So, the sound Krakatoa produced reached more than 170 decibels at a distance of 100 miles. And sailors aboard a ship just 40 miles from the eruption had their eardrums burst from the sound. The explosion's reverberation was so powerful that it was heard 3,000 miles away. In fact, at a farm in Alice Springs, Australia, over 2,200 miles away, sheep farmers reported hearing what they thought were gunshots. The sound from Krakatoa traveled around the world multiple times. Although no one heard the explosion beyond 3,000 miles, spikes of atmospheric pressure were recorded in places as far away as Canada and England. Those must have been the sound waves produced by the eruption traveling around the globe. Sound above 150 decibels can potentially cause life-threatening harm. In particular, sounds between 170 and 200 decibels can result in lethal conditions, including burst lungs. Anything over 240 decibels could cause fatal injuries, and you don't even want to know what those are. I'll just say that those sometimes happen to cartoon characters, but rarely to people. The scientific explanation behind this is that sound is essentially a wave of pressure, which can travel through both solids and liquids. And, in the case of an incredibly loud sound, pass right through the human body. If the pressure from such a sound is high enough, it can rupture eardrums and internal organs, causing significant and often fatal damage. Now, you probably know how volcanoes sometimes have small earthquakes before they erupt. Well, they often produce this weird sound called a harmonic tremor. The sound kind of hums, and the frequency of the hum gets higher and higher until it suddenly stops just before the volcano erupts. The sound has been recorded at a bunch of volcanoes around the world. But the thing about Redoubt Volcano in Alaska is that its tremor is so intense, people can actually hear it. It's like the volcano is letting out this crazy scream right before the eruption. According to a geophysicist at the University of Washington, the frequency of Redoubt's harmonic tremor is so high that it is barely perceptible as a low bass hum, and that's at its highest pitch. All because the pitch of Redoubt's tremor exceeds that of any other recorded volcano. It questions the limits of the existing models used to explain these phenomena. That's why researchers had to propose a new model to account for these unusually high-pitched tremors. Most volcanoes produce sound when magma bubbles vibrate as they rise through cracks in Earth's crust. But in the case of Redoubt, scientists believe that the harmonic tremor and associated earthquakes occur when magma is forced through a narrow opening under immense pressure. The thick magma sticks to the rock surface inside the conduit, a channel or pipe that carries magma from a reservoir or chamber to the vent. As the pressure builds, the magma moves upward. This makes it stick again until the pressure forces it to move once more. These sudden movements cause small earthquakes, which, as the pressure increases, occur more rapidly and blend into a continuous rising noise. So it's actually the rocks making the sounds. This new model is important because it could help scientists better understand the eruptive cycles of volcanoes like Redoubt. It could also serve as a limited early warning system. By the time Redoubt began to scream like this, the volcano had already been erupting for a few days. So the tremor might only provide a few minutes or hours of warning before the next explosion. The harmonic tremor at Redoubt reaches an extremely high frequency, then falls eerily silent before the volcano erupts again. This pause occurs when the earthquake activity slows down and the two sides of the fault slip smoothly against one another. Maybe that's when even earthquakes can't keep up anymore. The new model may also apply to other volcanoes, such as the Soufriere Hills volcano on the Caribbean island of Montserrat. The research team is now planning to investigate why the pressure at Redoubt is concentrated in one specific spot. To move ahead in their research, the scientists have created 2 recordings of Redoubt's seismic activity. The first, a 10-second recording, compresses about 10 minutes of seismic sounds and harmonic tremors, sped up 60 times. The second, a 1-minute recording, condenses roughly an hour of activity, including more than 1,600 small earthquakes that had occurred before Redoubt's first explosion with harmonic tremor. These recordings could provide crucial insight into the dynamics of volcanic eruptions and the signals that precede them. The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project, named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes. Roofs fly off like paper, huge trees are yanked from the ground, power lines snap and leave neighborhoods in the dark. Streets flood like rivers, homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole, a huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, two thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita Scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms, as well as fewer tornadoes, are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the U.S. could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following: warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the U.S. The risk moves around depending on the time of year and the weather.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack two Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. There's nothing around, just the eternal, endless whiteness of Greenland's snow and cold winds blowing into your face. Nothing hints at the impending catastrophe. You take another step and freeze in horror. An abyss is spreading at your feet, bottomless and dark. If you had made a bigger step, it would have swallowed you. That infamous Greenland's hole. It happened in the middle of the 2010s. A group of geologists were scanning the surface of Greenland's Hiawatha Glacier using radar when they spotted something very, very strange. It was a giant pit, more than 980 feet deep and almost 20 miles wide. That's big enough to fit inside Washington, D.C. or Paris. After staring at their radars for quite a while and scratching their heads, researchers decided to find out what could have made such a huge hole. Could it have been good old erosion, a raging volcano, an asteroid impact, a giant sandworm? Ugh, I might have gone a bit overboard with this worm idea, but you never know with these ancient glaciers. Anyway, in our case, one mystery seemed to lead to another, which had been puzzling scientists for decades. And to solve both of them, scientists needed something super common, but at the same time very important: quartz, one of the most abundant materials in Earth's crust. But before we dig deeper into this topic, let's make a small detour and talk about a pretty bizarre phenomenon called the Younger Dryas event. To see what it was like, we need to go deep into the past, as far back as 12,900 to 11,600 years ago. During that period, the planet became much colder, especially in Europe and North America. Now, let's talk a bit more about that weird climate change in the Northern Hemisphere. There are a few theories. One that involves a change in currents in the Atlantic Ocean. Another speaks about something large kicking tons of dust into the air and effectively blocking sunlight. The two most popular and likely hypotheses mention a volcanic eruption and an asteroid impact. Indeed, there was a volcanic eruption on the territory of modern-day Germany at around the right time. But there's also a probability that a space object struck the planet during this period too. And now let's get back to the hole scientists found in Greenland. When NASA's Ice Bridge program and Germany's Alfred Wegener Institute discovered it, it seemed they had finally found the reason for the Younger Dryas event. But was it really an asteroid that created that impressive pit and caused temperatures to drop all over the Northern Hemisphere? To test this theory, the researchers needed quartz. The thing is, in its pure form, quartz has a very simple structure. It's made from interlocking silicon-oxygen tetrahedra. Efficient and so pretty. Just look at these six-sided prismatic crystals. Since its structure is so simple and the components are so common, you can find quartz almost in any rock on the planet. At one point, magic happens. Larger rocks erode away, pushing out tiny bits of quartz sand. The scientists exploring the mysterious pit gathered the quartz sand that had been washed out from underneath the glacier. It was like looking at the rocks at the very bottom of the hole without having to actually get all the way down there. Very handy. So while examining the material, they discovered quartz grains with the telltale signs of terrible catastrophe. They had PDFs all over them. No, I'm not talking about the document format. PDFs stand for planar deformation features, and they look like lines etched into the crystal surface. These lines are a sign that you're holding shocked quartz. It forms under immense pressure, when the internal crystals are pushed out of alignment. But the most exciting thing here is that shocked quartz only appears under the influence of powerful forces, like massive impacts or terrifying explosions. In other words, finding this poor shocked quartz under the Hiawatha Glacier could be much-needed proof that the hole was an enormous impact crater that formed when something equally enormous crash-landed there. Based on the size of the crater, this space object probably was a bit more than a mile across, which is twice the height of the Burj Khalifa Tower in Dubai. A meteorite that big would have looked 3 times as bright as the sun when traveling across the sky, and it would have hit Earth with an immense force. The impact would have been so great it'd have vaporized rock and thrown debris for hundreds of miles away. The sky would have filled with dust. It would have dimmed the sun and led to a temperature drop all over the planet. And guess what? The last part about decreasing temperatures got the researchers super excited, because it opened up a possibility that the impact could have been connected to the Younger Dryas event. To prove this idea, scientists decided to use quartz again. They examined it more closely, trying to date the impact. Well, they were in for an even greater shock. The Hiawatha crater turned out to be not 12,000, but 58 million years old. On the other hand, the researchers were disappointed that they hadn't been able to confirm their theory. The crater couldn't explain the Younger Dryas cold snap, but on the other hand, it was still an amazing discovery. Now, get ready for one final twist to this story, and it revolves around quartz again. Other scientists have recently discovered more deposits of shocked quartz all over what is now the eastern USA. It was hiding in sediment layers dating to just before the Younger Dryas. Interestingly, there aren't any craters around those sites whatsoever. But quartz can't lie. It provides evidence of a powerful explosion. It makes scientists think that their impact hypothesis might still be true, but instead of a collision, it could be an airburst. A massive comet could have broken up while entering Earth's atmosphere around 12,000 years ago, and the fragments could have exploded before reaching the ground. It would have caused catastrophic mass burning throughout the North American continent and messed with the climate so much that the Younger Dryas would have been triggered. Well, I guess we need to wait a bit longer for scientists to find some further proof of this hypothesis. But it doesn't mean we don't have any more curious phenomena to explore in Greenland. Take these fascinating holes. They sure are kinda smaller than the monster we were talking about. They're called moulins, and they carry surface meltwater all the way down to the base of the Greenland ice sheet. And they have prepared some surprises for us too. Apparently, they're way larger than we previously thought. That's what a recent study based on observation and first-hand exploration claims. Even more interesting, this high volume might influence the stability of the ginormous ice sheet in question, as well as the speed at which it's sliding towards the sea. Researchers think that increased water depth and pressure inside moulins might lubricate the base of the ice sheet, making it move faster. You know, the way an ice cube slides more easily on a thin film of melted water. Until recently, we knew too little about the real size of moulins and how much water they can hold. But now, we know that moulins can be giant. The team made 2 trips to the Greenland ice sheet in 2018 and 2019. And during each of them, they used ropes and climbing equipment to drop around 330 feet into 2 separate moulins, almost touching the water's surface. Those who did it described the experience as intimidating. Picture this. Your back is over the edge. All you see is bluish ice going down and blurring into blackness. And the only thing you hear is occasional sounds of crashing ice. It must be extremely unnerving.
Deep under the Indian Ocean, there's a giant patch where gravity doesn't work like on the rest of the planet. I mean, the gravitational pull works constantly, but Earth is not a regular sphere. Its surface is not smooth. It's covered with lumps and bumps like a potato, because our planet is not the same everywhere inside. Some parts are denser than others. Let's say you could pour water across Earth's surface. The shape this water would make is called a geoid, and it's like that because of the differences in materials inside the planet. That's why gravity isn't the same everywhere. And down there, in the dark depths of the Indian Ocean, it's weaker than usual. That spot is something we consider a giant gravity hole that stretches more than 1 million square miles in size. It's roughly where the ocean floor sinks down in a giant depression. Scientists used ships and satellites to figure out this mystery. They realized the water level near India was lower because of this weak gravity spot. They're still not sure what made gravity become so weak in that area. But 2 Indian researchers realized everyone was trying to understand this, considering what that area looked like in the present. So they decided to go to the past. They used computers to make models of a virtual Earth and figured out that the answer could lie over 620 miles under the surface. That's where a part of an old ocean sank 30 million years ago, causing a hot melted rock to move around. And this mixture might have made gravity weak in that area. It's a really interesting idea, but it's still not the final answer. In 2018, a team of scientists from India went to the Indian Ocean with special machines to listen to the ground rumbling, similar to when you hear thunder. They found out there were hot streams of melted rock coming up from deep inside Earth. Could they be part of the reason why the gravity is weak there? We'll need more information to understand the issue better, maybe even go back further into the past. For instance, about 140 million years back, the land was all connected as a big piece called Gondwana. But then, India started moving away from it. While India was moving, an old ocean floor called the Tethys Sea sank into Earth's insides. These 2 scientists from India kept trying to solve the case, using computers to pretend to be going back in time. They checked how the land moved, as well as the mantle, which is basically a thick layer of hot, solid rock. The duo found out that a long time ago, there were hot, light rocks rising from deep inside Earth. These rocks created a spot where gravity was weak. This spot was like a big dent in the ocean floor. The more these rocks rose, the deeper the dent became. The first of these rising rocks popped out around 20 million years ago to the south of the weird gravity dent. As these rocks moved and went under the land, the dent got bigger and stronger. The 2 scientists think these rocks were pushed up by the sinking old ocean floor, like bubbles. This process disturbed something called the African blob. You gotta see this. Deep inside our planet, there are 2 very big blobs, like giant pieces of rock, as large as continents. One is under Africa, and the other is under the Pacific Ocean. These blobs have roots that start almost halfway, 1,800 miles, toward the center of Earth. And they're probably the place where columns of hot rock rise up from way down below. When these hot rock columns reach the surface, big volcanic eruptions happen. And we're talking about some really massive ones that might have even played a role in erasing dinosaurs from the face of the Earth a long time ago. So, we don't want these giant blobs to be disturbed. Anyway, not all scientists agree with the theory about why gravity doesn't do its job in this particular spot in the Indian Ocean, saying they need more proof to be sure about these rising rocks. The real answer might come from listening to Earth's rumbling. Plus, who knows if this gravity hole will stay there forever or move away. It depends on how Earth's mass will shift around. To see some changes might take a very, very long time. Maybe even hundreds of millions of years. That's not the only region where gravity works in mysterious ways. Or at least, that's what it feels like when you see certain things around the world. Like, what if you saw rocks that don't sink, but can float on water for a very long time? They can even travel around for thousands of miles until they finally find a spot where they sink. Scientists figured out how this worked by using special X-rays to check the insides of these rocks. and these unusual rocks turned out to be very light and full of tiny holes. Researchers used wax to cover pieces of these rocks and went with a special X-ray method to look inside the rocks to see how much water and gas was there. The reason these rocks can float is because of something called surface tension, which is like a very thin, the size of a human hair, layer of air on the water's surface. This helps some animals, like lizards and insects, to really walk on water. And these floating rocks are not just cool because they travel, but also because they can actually help scientists find underwater volcano eruptions. They can also carry living things across oceans since they tend to collect some plants and other things rich in nutrients. So it's basically like a free cruise, until you sink down at some random spot. No iceberg needed. Here you have floating rocks. And in Death Valley in California, there's a strange phenomenon where big rocks move across a dry lake bed and leave trails behind them. People wondered how this was possible for 60 years until the case was solved. Some thought there must be strong winds moving these rocks, or maybe even ice. But scientists found these winds aren't really strong enough to move such big boulders. They placed cameras on cliffs near the rocks, even though they were hard to reach. They did this for 3 winters in a row to study the temperature, rain, and wind in the area. Their idea was that ice might lift the rocks and let the wind push them. To test this properly, they put a rock in a container with water and sand and froze it. When they later pushed the container, the rock moved like it was on ice. This experiment helped prove their theory. And what's interesting is that the rocky area in Death Valley is similar to one of Saturn's moons, Titan. So these weird things on our planet may help us understand other phenomena, even in space. The reverse waterfall in England is an example of a spot with weird gravity too. You can find it not far from Hayfield. It has water that looks more like a fountain than a waterfall, considering it goes up toward the sky. But it turns out gravity doesn't have anything to do here. It's just the wind. It's so strong that when the water falls down, it catches it and pushes it back up. But where does this constantly strong wind come from? You can see a similar thing at Hoover Dam in Nevada, US. Try to climb up the dam, 726.4 feet, and pour some water out of a bottle. Not working? Yep, the water won't flow down as it normally would. It will fly up. You'll have the same result if you throw some light object from the same height. You will get it back. And this happens because of the strong airflow too. So these things seem like gravity is messing up with us. But there's always a logical answer behind that. Hopefully, we'll get one for the gravity hole in the Indian Ocean too.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank 1 bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words,
The cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. The recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We've observed such changes for the first time, but they're likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. Now, the inner core of our planet, located about 3,100 miles below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. Now, this outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we really didn't understand its impact on the inner core, but now The new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core, and that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we really don't notice these changes, but they could influence Earth's overall rotation and length of days. The study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It also allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped, and this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists can also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of our core. But what would happen if Earth's core suddenly stopped spinning altogether? Well, it's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movements, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers or on the floor. The planet would experience something similar, but with tectonic plates. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the Sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime or ever. So for now, we're safe. But to truly understand Earth, you need to go 4,000 miles beneath our feet. Earth has four main layers, from the very center to the surface: the inner core, outer core, mantle, and crust. Now, except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 7.5 miles, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 758 miles in radius, which is about 3/4 the size of the Moon. It sits about 4,000 to 3,200 miles below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 9,800 degrees Fahrenheit. It's like the surface of the Sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests that there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 3,200 to 1,800 miles beneath the surface. The heat here comes mostly from the radioactive decay of elements, like uranium and thorium, causing the liquid to churn in massive, turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer, stretching almost 1,800 miles deep. It starts just around 19 miles beneath the surface. Made of iron, magnesium, and silicon, it's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 62 to 124 miles underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 124 miles. But rarer, super-deep diamonds may form as deep as 435 miles. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it's the outermost layer of Earth. It's about 25 miles deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe.
7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today. Robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical megaquakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia Subduction Zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent. And it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate megaquakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the